Okay, so looking at this picture, what can you see marked in there? What's marked in it? The angle of 42. Yep. Do you see anything else that's marked? I see parallel lines. There's the parallel. Okay? They tell you right here. Okay? They do tell you parallel lines. And there's not much else that's marked. That's all we're given. Okay, so let's go from there. Now, there is something that you guys should know. When you have parallel lines, okay, when you have parallel chords, their arcs are equal in measure. Okay? What does that mean? They're trying to tell you this. This is equal to this. That's what they're trying to tell you when they say parallel lines. Okay. So if this angle right here is 42, how much is this arc? It's 84. Remember, 2 times the angle gives you the arc. So since I'm going from here to the arc, we multiply by 2. So that makes this 84. Okay. Now again, this arc and this arc are in between the parallel lines, so they are equal. So this is also 84.
So wouldn't also the other angle be 42 on the AN?
Yeah, and I understand what you're saying. He's saying, isn't the other angle, could you give it a 3-letter name, Jace?
ABD?
Not quite. BAD is the correct angle, Jace. You have to start at the edge of the circle and come back, because we're looking for these, yes? This connects to this. So we have to follow it in that order, B to A and then out to D. So yes, you're correct. This angle right here would be also 42 degrees. Okay. All right, so we kind of understand some of what the picture is. Now we need to go to the actual question. All right, we already have the idea that these are parallel. We got the idea that this was 42, but we didn't get the rest of what they were trying to give us because we didn't read it. I can't find AB without having read the question. And the measure of arc CD is twice the measure of AB. Do you even know what AB is? So what do you put in for it then? Arc AB is now my x, and it says that CD, arc CD, is twice the measure. So what does that make arc CD?
2x.
That becomes my 2x. How do I solve this? X plus 2x. Whoops, I almost wrote 24. X plus 2x what? Close. I am going to have an equals 360, but...
I got it. Okay, so, look, miss, the whole thing is 360, right? That's 84, that's 84. All you gotta do...
As Harsha was saying, and Hapton was adding, and now Rakim has stated it.
You gotta, then once you get the 84
Okay.
plus 84...
Now I'm going to...
You subtract that from 360, then split that in half. That's how you got that and that.
Okay, so now we solve this, and you need to simplify it.
Yeah, I tried.
Okay?
I tried.
It's not that I didn't understand. They need to understand.
Okay.
So
I'm gonna say
Hapton was starting to say that I'm going to take that 360 and subtract off the two 84s because I need to reduce it. I already have those arcs. I need to find the missing ones. This becomes 3x.
Yep.
And when I combine these, it becomes 168. So yes, I need to subtract off the 168 from the 360.
192.
And then we would divide that by 3. Okay. So now, they didn't ask us to find x. They asked us to find the measure of arc AB. Did you find the arc of AB?
Yeah.
Yes, because it was x. This one is 64. Then that makes this one 128. So now we know all the arcs everywhere. And you know all the angles everywhere. But the key concept to this one, I couldn't even approach that until I knew that arcs in between parallel lines are the same.
But why, what that? That's what I'm trying to.
Where'd what come from? 128?
Oh, no, that's because 64.
Oh, yeah, 64. 2 times 64 equals 128.
I'm trying to.
We're not really awake this morning.
3x. 168.
Okay, so in this picture, you see a whole lot going on. What's one thing you should recognize in this picture right away? The diameter. Always be able to recognize the diameter right away. And I'm not going to go through all these questions because they're not that important. My important part is, can you recognize all the different pieces going on? If this is the diameter, what's happening? It's being cut in half. Okay, so I'm going to ask a question. How much is angle E? How much is this angle right here? How do you know it's 90 degrees? Okay, yep. You have this half a circle. This leads to this,
Angle E?
which is half of a circle. That leads you to half of a circle, which is 90 degrees. If this half is 180, then this is 90 degrees.
You sure?
Positive is 90. It has to be 90 because this is an inscribed angle. So this angle is half of its arc. Okay, how much is angle F?
F? Where's angle F? 90. That's 90 degrees too.
How do you know that that's 90 degrees?
Because it's the, I can't think of the word that I just said.
These two chords
There.
reach to what?
Half of 180.
The half of the circle, which is 180. So this angle up here is how much? That has to be 90. So now we got another 90 degree angle. Okay, next question. How much is angle D? How do you know it's 90? Again, it touches here, and it gets the other half of the circle. So I take half of it, and it leads me back to the inscribed angle. That one's also 90. So now we know that right now I have 1, 2, 3 90-degree angles in here. Why? Because they led you to the diameter, which was half. And since E, F, and D are all inscribed angles, then they're half of their arcs. Okay, so now we're going to answer question C. Okay, if the radius of circle A has a length of 5, where are they talking about for the radius? If circle A has a radius of 5 inches, name the radii. This is C, and I believe this is B. So what two radii do you see? AB and AC. This radii is 6, and this radii is 6. and BD is 6. What's the length of DC? You think it's 12? Okay, so this whole thing would be 12, right? And this is the what of the circle? Diameter. Now, quick question. This right here, is that a diameter? Nope. So it's not going to be the same length. Anybody else got something else for me?
Is measure of DC?
The measure of DC.
Segment or the chord?
The chord right here, not the arc. I don't want the arc. I don't want the arc from D to C. I want the chord of D to C, the length of DC, the segment. Any suggestions?
11.6.
It sounds close to being about 11.63. The question is, how do you know that? He's right. You use the Pythagorean theorem, and I'm going to highlight it in orange. What shape is that? It's a right triangle. Okay? And we learned the other day when we were doing SOHCAHTOA that you cannot use that to find just missing sides. SOHCAHTOA is for angles and side lengths. If we're missing this, if we don't know what this is, because this is a right triangle, we would do a squared plus b squared equals c squared. And a is 6, or a could be your x, it does not matter. But what's the c in the orange?
I like the hypotenuse.
It is the hypotenuse. C is the hypotenuse, which is all of the diameter. Now, they told you that the radius was 6, but this whole thing is 12. Here's your right triangle, so this is your hypotenuse, which is your C. So that's 12 squared.
Yay.
Now, it does not matter which one of these sides you call A or B. Most people like to call the missing side their A because it makes it easier to solve. It's in a way that they understand. Okay, so we get 36 equals the 144. You take this off, and then we solve this. And then you take the square root at the end. Okay, so it's a review of the Pythagorean theorem. Okay, so then we take the square root. But you would not be able to know that you could do this Pythagorean theorem until you knew you had right triangles. And that was the importance of looking at all those arcs. Yeah, you're supposed to get a decimal, which is 10.39. It doesn't tell you what to round it to, so I'm going to leave it as that. So taking what we learned yesterday to the extreme. Will you see anything extreme on the final exam? No. Could you see something to the extreme on the Regents exam?
Yes.
Yes. Guaranteed? No. Okay. All right, I'm going to flip the page. Okay, so not too bad. But in these triangles, hopefully you guys can recognize right away when you guys have right triangles. Do you see a right triangle here? How do you know and how do you prove it? That is your diameter, which means that this part of the arc is 180 degrees.
The angle of ABC must be half of.
That is half of your 180 because the chords lead you to the diameter. If the chords from an inscribed angle lead you to the corners of the diameter, then indeed I do have a 90-degree angle. They are trying to tell you that this is a right triangle. They tell you that AB is 5. They tell you that only from O to C is 8. Then they want to know the arc here to the nearest degree. So I would need to know the Pythagorean theorem somewhat first. Not quite the Pythagorean theorem, but I'll teach you the one I'm talking about. If this is 8, what else should we know as 8? AO is also 8. Okay, so that makes this whole thing 16. Now, the question they asked you is how much is this arc here? This arc leads you back to what angle in the triangle? It doesn't. This arc right here, from C to B. But follow it back. Here's the arc, right? Follow it back. What angle does it land me at? It lands me to this angle. Now, the question is, do they ask me for the length of chord BC? No. So I'm not looking for the missing side of the right triangle. I'm looking for the arc. The arc means I need to find an angle in the right triangle. Now, last lessons that I have been doing, when I did them with you guys, it was SOHCAHTOA versus a squared plus b squared equals c squared. When do you use SOHCAHTOA in a right triangle, and when do you use a squared plus b squared equals c squared? So SOHCAHTOA, when you have angles and sides, and Pythagorean theorem is when you have sides only. Now the question is am I looking for a side? No, I'm looking for an angle measurement, so I must use SOHCAHTOA. Must use SOHCAHTOA. So the question is, what is this according to your right triangle? That's the hypotenuse. What's the 5 according to the angle? Adjacent. And which theorem am I going to use? So, ka, or toa? Ka. I need to do the cosine of the angle A that I'm looking for is equal to the adjacent over the hypotenuse. So I'm blending now. We're blending that concept of what we just did for the trig ratios with this. Now the question is, can you put cosine of A into your calculators? So what must I do in order to find the angle? Well, if you cross multiply, you're still going to get cos of A times 16, and I can't even put that in the calculator. Okay, so on one of the lessons that I did with you guys, we talked about if you're missing the angle, you will use the second button. You will do second cosine, so that way you'll get cos of -1, and then you just type in 5 divided by 16 to get the angle measure. Yes, because it says to the nearest degree. Okay, so I did it. I got 71.79. But I don't want to round yet. How do I get from this angle to this arc? Do I divide it by 2 or multiply it by 2? I multiply it by 2. So now in my calculator, I'm just going to hit multiply, because it'll take the answer from up here, and I'm going to multiply by 2. And I'm going to hit enter. What is this to the nearest degree? Nearest degree, yes, would mean the whole number. So not 143.6. They're looking for that this arc is 144 degrees. Because we're essentially taking what we got here and multiplying it by 2 to get to that. Okay. Any questions? All right. Now, I apologize for your warm-up because this helped home is where I would have seen this. Just really quickly, and then I'll assign your guys' homework. This is the warm-up. If you add those two angles together, you get 180. Here, if you add these two angles together, you get 180. So this is where that would have come in. Okay, if you add opposite angles within a quadrilateral inscribed in a circle, the opposite angles are supplementary. Okay, any questions? Okay, so your homework, and you have time, you have 6 minutes, okay? Okay, I'm going to have you guys do 3, 4, and 5. 3, 4, and 5. Okay, 3. This is on page 11 and 12. You're going to do 3, 4, and 5. So again, those of you guys that still haven't gotten it, page 11 plus 12, 3, 4, and 5. Now, if you have any questions, you have time to work on it now. You have 6 minutes till the bell rings. I will answer your questions.